Hi guys, and welcome to our lesson on interest rates over different time periods and effective interest rates. Whew, again, can we make these titles shorter? My name's Darren from Maths Guru, and this is another video in our Year 12 General Maths series relating to the financial maths component. Hopefully you have found the previous videos useful. This is the last one in this particular chapter, if you will, before we move on to the more interesting stuff, dealing with financial solver and financial maths and all the funky stuff that's going to come with it. Now, before I get any further, the only thing I ask for you to do, if you would do me a massive favor, is go to my YouTube channel, Maths Guru, and basically just subscribe. If you need to, turn off the notifications. I get it, all right? I don't want to annoy you or any of those things, but by doing that, it just shows me that people are actually watching. Maths videos aren't normally high on the list of people going, yes, 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 I must subscribe. Allow this person to know. Now, what I normally do is I run through the learning objectives, but by the time you're in Year 12, I'm fairly sure if you want to, you can actually pause the video and have a read over. But it's just going to cover the stuff for basically the Cambridge textbook. Now, Cambridge have been awesome. They've allowed me to use all of their examples. You guys rock. Thank you very much. So that I can align this course with the Cambridge book. But if you're following from another textbook, it doesn't matter. The content is pretty much going to be the same. Now, in all the videos we've dealt with before, as I say here, we've only been looking at interest being paid once a year. You've been given a per annum figure. And we may have put it into any number of rules or recurrence relationships, but generally speaking, we've had interest paid just once a year. Well, that's not realistic, is it? I mean, at the moment, every month, the RBA are putting up my interest rate for my house, so I won't be able to do these videos for too much longer because I will be homeless, and that's probably not even a joke. But you can head over to maffsguru.com and sign up. Yes, I know. I don't know what that's got to do with the price of fish, but yes, maffsguru.com. You can basically go and sign up there, absolutely free. All the videos are there, downloadable notes and all that type of stuff as well. But it's not realistic, all right? Interest is generally charged monthly. It can be charged quarterly. It can be charged daily. And depending on the circumstance of the question, depends on which sort of calculation that you're going to use. But I'll come on to that later. Now, when you pass banks, you might see really, really big rates like this. I mean, that's actually quite small in comparison because obviously it's an interest rate. If we were dealing with mortgages, there'd be like a big 8 or maybe a big 5 at the moment, and they go 5% PA. And that's little asterisk that makes all of the difference. Why? Because basically it's the small print that becomes important, because that is what we call a nominal interest rate. I know, go Barry, thank you very much for another stupid name. But it is a nominal interest rate. Why? Well, it's a yearly one. But what we find out in this video is actually you will get charged more interest than you actually think, depending on how often interest is charged or paid. All right, so that's really the premise of this video. Now, the thing that always surprises me is there's lots of general maths kids who basically don't know how many months there are in a year, how many fortnights there are. That's a bit more complicated, I suppose. There are 52 weeks in a year. So if there are 52 weeks, there's got to be 26 fortnights. There are 4 quarters in a year, and believe it or not, 365 days. Well, 365 and a quarter, but let's not split hairs. I don't have much of that left. Now, interest rate conversions are used extensively in SACs and the exam. You have to get used to doing this. I do it slightly different than the textbook. The textbook has sort of changed it for the new study design, but I do talk over it a little bit later on, all right? But it's important that you know how to decode the question, reading the language in the question to allow you to effectively use the right rate of interest. So, for example, if I have a 12% annual interest rate, right? So if my interest rate is 12%, then what we actually do, if I wanted to know what my monthly interest rate is, well, I actually take my annual rate and divide it by 12. So what we're effectively getting is 1% per month. Now, for those of you who are ahead of the game at the moment, you'll be like, hold on a moment, but what about the compounding stuff, right? Don't rush. But yes, basically, there is going to be an issue here. So if we go back to some sort of basic examples first, let's see what we come up with. An investment account will pay interest at a rate of 4.68% per annum. So that's my nominal rate. Convert this interest rate into one for a month. All right, well, okay, I know there's 12 months in a year. So all I would do is 4.68% divided by 12. Now, I can't do that in my head and have no reason to do so. For those of you who know my videos, you'll know that generally speaking, my Casio ClassPad emulator doesn't seem to work at the moment. Where the functionality is massively different, I'll let you know, but pretty much every calculator on the sun will actually be able to do 4.68 divided by 12. And so 4.68 divided by 12 gives me a monthly interest rate of 0.39. And it's really interesting or really important to put that percentage sign there. All right, so just make sure you understand that. Now, as I say here as well, you also have to do the conversion the other way around. So if I gave you 0.39% as a monthly rate, could you take it back to a nominal rate? That's going to be really, really important. And again, the type of stuff that happens in SACs. All right, whoops, let's go back to the next one. I basically thought that I'd actually split this over 3. So what about fortnightly? Well, how many fortnights are there in a year? Well, there's 26 of them. So in this situation, I would do 4.68% divided by 26. And again, I've got my calculator ready. So 4.68 divided by 26 gives me 0.18%. And quarterly, well, there's 4 quarters in a year. So 4.68% divided by 4. So 4.68 divided by, 4.68 divided by 4 gives me 1.17%. Ka-ching. That is all there is to do it. Now, obviously, you're going to have to use these percentages in different contexts later on, but it's important skill to be able to say, well, in the question, is there an annual rate? And are they compounding it in a different way? And again, that's language we're using, but are they compounding it monthly, fortnightly, quarterly, daily, weekly? They will all come up in the question. All right, now let's go to the right slide. Brian borrows $5,000 from a bank. He will pay interest at a rate of 4.5% per annum. And again, because that is a per annum rate, that is my nominal rate. Let V and be the value of the loan after n compounding periods. Now, because we are dealing with multipliers here, we're going to get interest on the interest on the interest on the interest, right? Now, if you're not sure what's going on, stop the video, go back and watch previous ones. Again, they are on mathsguru.com. All the notes I'm doing behind me you can download. Write down a recurrence relation. And as I said to my students over and over again, if you don't understand the difference between a recurrence relation and a rule, unfortunately, you're going to get seriously tricked, probably in any SAC or any exam, because there is a very distinct difference. And I've done a video on how to change those as well. But write down a recurrence relation. So I know a recurrence relation must start with V0 equals, and in this situation, it'd be $5,000. Why would it be $5,000? Because that's basically my initial amount. That's how much we borrowed from the bank, or Brian borrowed from the bank. What have we got now? So, value of Brian's loan if the interest is compounded yearly. Now, in that situation, we are charged interest once per year. So, in that situation, I would now have V of n plus 1 equals, right, what is my multiplier going to be? How on earth am I going to work out my multiplier? Well, I always do it this way. I go my little r, in this situation, is 4.5. And I know to get my big R, which is going to be the value of my multiplier, I do 1 plus my little value of R divided by 100. Right, fire up my calculator. So firing up my calculator, 1 plus 4.5 over 100, hit enter, is 1.045. That's my multiplier. Where am I going to put that? Well, let's just move this over a little bit so that I've got some space. He said with my calculator still on. So it becomes 1.045 times V of n. Ka-ching. That's literally it. I've worked out my interest rate. Now you're going to say that's pretty much what you've been doing before. Absolutely. Because every example we've done before has been yearly. But what are we going to do now? Well, we're going to change the question. And there we go. So now we're going to look at quarterly. All right. So I've cleared the screen or come to a different slide. Now, this is where I do things slightly differently in the book. The book says something like 1 plus R on, I don't know, P times 100 or something. I don't do it that way. I always do it the same way. I say write down what my little r is. At this moment, it's 4.5%. But I'm compounding. So because it is quarterly, I'm now going to change this little r value to 4.5 divided by 5. Now I'm going to do this off screen for a moment. So 4.5 divided by, I think I said 5, I meant 4. Gives me 1.125. That's my little r. Now the reason I keep it that way is because I always now do r is equal to 1 plus r on 100. I'm just changing my value of r. So my big R then becomes 1 plus 1.125 on 100. And again, if you don't mind, I'm just going to do that off the screen. 1 plus 1.125 divided by 100 gives me 4.5 divided by, see, 4.1, yep. just checking my calculations, it gives me, so my V0 is going to be giving you 5,000. V of n plus 1, because remember this is a recurrence relationship, and my multiplier came out as 1.01125 times V of n, right? Again, recurrence relationships always start with V0, have V of n plus 1, a V of n, and in this situation, because I'm compounding, my R value is not 1, all right? It's going to be bigger than 1 because we're adding on the interest. And the next one, what about if we do this monthly? What do you reckon is going to change? Well, my V0 is still going to be 5,000. My V of n plus 1 is still going to start my formula. My R value in this situation is 4.5. That's my nominal rate. But I'm now going to divide it by my compounding period. So I'm now going to divide that by 12. So again, doing this off screen, if that's okay with you guys, 4.5 divided by 12, if you will, gives me 0.375. And so my big R is 1 plus my little r of 0.375 divided by 100. I like to keep things the same, all right? The only thing I'm changing here is basically I'm changing my nominal to a monthly or quarterly or yearly interest rate, all right? So it just to me makes a sense and to keep this formula as 1 plus r on 100. So again, if I do 1 plus 0.375 divided by 100, hit enter, gives me write it in pen, 1.00375. Now a lot of people go, I can do that in my head. Marvelous, so can I. And the number of times I've done that and missed a zero, and everything else goes horribly, horribly wrong. So it's a calculator course. I'm going to use a calculator. And there we go. So that basically is now turning our interest rates in 3 different examples into a yearly, quarterly, and monthly recurrence relation. And again, what you've got to realize here is this performance, this recurrence relationship will give you month on month on month. So this is telling me if I start with $5,000, if I want to know how much I've got at the end of my first month, I would do that once. Second month, I would keep it. The third month, I would keep going. When I did it with quarterly, it would be how much would be every 3 months. And the context of these questions becomes really, really important. Here's another example. A principal value of $10,000 is invested in an account earning compound interest monthly at the rate of 9% per annum. Now, notice what they've done here. They've said that it is compounding monthly. So automatically, I know my dividing is going to be 12 because I've got an annual rate of 9. So in this situation, little r is going to be 9 on 12. And that's just what I do in every case. So calculate the growth multiplier R. So looking at part A, so my capital R is going to be 1 plus. Well, again, not doing this on screen because hopefully you are happy that you can put 9 on 12. Gives me 0.75. So 9 divided by 12 is 0.75. That's my little r. Divided by 100. Again, put that into my calculator. 1 plus 0.75 divided by 100 gives me 1.0075. So the answer to part A then would give me that R is equal to 1.0075. Next, write down a recurrence relation for the value of the investment after n months. Now again, because this R is monthly, my recurrence relationship, part B, starts with V0, is $10,000, comma, V of n plus 1 equals, well, we've already got my R value now monthly. We've already done the hard work. 1.0075 times V of n. And ka-ching, we is done. Part C. And realistically speaking, a lot of the questions that we do scaffold in exactly the same way. Write down a rule. Now, obviously, in this situation, we've got to be careful. Do we know how to turn this recurrence relationship into a rule? Well, I know rules always start with V of n. I remember because either I'm like 147 or it's in my summary book that I then write my value of V0, which is 10,123. I'm going to times that by, it is always the multiplier, 1.0075, and I raise it to the power of n. And again, when you raise it to the power of n, make sure that n floats, because if it doesn't, you is in all sorts of trouble. Part D, use this rule to find the value of the investment after 4 years. Well, what are they telling me here? They're basically telling me the value of n is 4. So in that situation, I would say that V4 is equal to 10,123. Oh, hold on a moment. Did you see the trick there? Write down the value of the investment after 4 years. But I just told you a moment ago, this recurrence relationship is monthly. So do you see what I did there? They tricked me. Shucks. I would want 4 lots of 12. So that's basically going to be 1.0075 to the power of 12, 24, 36, and 48. All right, let's fire up my calculator and just do that then. So 10, 1, 2, 3 times 1.0075 to the power of, he says. So let's actually type this in now. 10, 1, 2, 3 times 1.0075 to the power of 48. Hit enter, and what do we get? Right, so we use this value to find the value of the investment is going to give me, so I'm not going to write 4 there, I'm going to write 48 because it's 48 months, and in which case it's going to give me $14,314.05. Now a lot of people say, do I need to round? Yes, absolutely you need to round because it's money. Always round to what it gives you, and if it doesn't give you as it did in this situation, money always has 2 decimal places. Now, a word of warning, guys, if you are using the TI Inspire, click Doc, hit 7, hit 2 to go to Document Settings. Make sure your calculator is on float, not float 1, 2, 3, 4. For some reason, float 6 seems to be a fabulous one. If you do float 6, you are going to get really horrible answers because it's only going to show you 6 digits of any answer. All right, so don't do float 6. Make sure it just says float. Let's turn the calculator right off and let's move on. Now, calculating the rate of interest. This becomes massive in amortization tables, which is basically chapter 8, exercise C, until they change the book around again. All right, so hopefully for the next 4 years will be good. All right, now I say the rate of interest. This is such an important formula. The rate of interest is given by how much interest was added. So a physical amount of interest divided by the amount before the interest was added. Now, in amortization tables, that's going to be the previous balance, times by 100. Now, again, when I get to this, it's going to become massive. It's really, really important. But just know that the rate of interest is going to become huge in the next section. All right. I talked a little bit at the beginning about effective interest rates, and I talked about, banks sort of advertising 5% and then telling you watch out for the small print. If you've understood anything about interest, the more times you add on interest, it begins to compound, it begins to grow, and it grows faster and faster and faster the more the interest is paid. Now that can be a good thing, and it can be a bad thing, and there's a VCAA question that hopefully, if I remember rightly, I've got coming up. So what I want you to do is imagine that I've basically walked into a bank, or 4 different banks with $6,000. I wish I had $6,000. Anyway, and what I have found in all of these banks is that my annual rate of interest is 9%. So that's my PA interest. My per annum is equal to 9%. What I've said to the banks is, one of you, please pay me interest only once annually, just once at 9%. One of you pay me quarterly, so that's every 3 months. Can one of you pay me monthly, that's every single month? And can one of you pay me daily? Now, for the purposes of this, there is no way I am having 365 columns on this table. We'd never fit it in. We'd never be able to see it. But I've worked out my interest rate for quarterly at 2.25%. If you're wondering why it's 2.25, I've done 9, which is my nominal, divided by quarterly, which is 4. That gave me 2.25. I've also worked out my monthly interest, which basically works out to be 0.75. Now, what I find out when I do that, and hopefully you'll check the interest calculations, but I'll show you how to do that in a moment, is when I do this annually and pay in $6,000, when they pay me interest only once, I get $6,540. So hold on a moment, how much interest did I get? Well, hopefully you're going, well, I started with $6,000, I ended up with $6,540. I've not paid any money in, so it must be $540. So ka-ching, in that situation, I got $540. I'm loaded. But if we start looking across the columns, he says going that way, what do I notice? Well, when I put in $6,000 at the start for one paying quarterly, I actually get more. I get $6,558.50. How? How am I getting more? Well, because here I'm getting interest, and then they're giving me interest on the interest, and then I'm getting interest on the interest on the interest. I am raking it in. Look at that, an extra, what is that, $18.50 just by them paying me quarterly. What about monthly? Well, again, I'm paying in $6,000. How much is coming out then? $6,562.84. I'm even more loaded. And again, when they pay me interest daily, I'm starting at $6,000 and I'm ending up with this. But hold on a moment, they all had the same yearly interest rate. Each of these banks advertised this account at 9%. But what I didn't see was the small print on the bottom. And in the small print on the bottom, they talk about effective interest rates. Now, banks being banks call it something really funky, and I can't remember what it is off the top of my head. But the more you are paid, or the more times you paid interest, the more you're going to get. Now, again, I want you to think about situations where that can be both good and bad, right? Coming back to that. But what is this effective interest rate? Well, basically, what we have noticed is, if I want to work out my effective interest rate, and I'll show you how to do that in just a second, when I am paid interest just once, it works out that I get 9%. Ka-ching. All right, well, that sort of makes sense because that annual interest rate of 9% is 9%. Hold the line one moment, I just need a sip of coffee. When we get to quarterly, suddenly I find out that I'm not getting 9%, I'm effectively getting 9.31%. When they pay me monthly, I'm getting 9.38%. And when they pay me daily, I'm actually getting an interest rate of 9.42%. Right? That is nearly 0.5% more than the bank are advertising at 9%. So you're going to say now, well, how on earth do you get these rates of interest? And that comes back to my formula. Now remember, my formula was to get the rate of interest. I take how much interest I was added. So I'm going to look at the first one first. Let's look at this first. How much interest did I get? I got 540 bucks. I'm going to divide it by how much I started with. So what was the initial amount I paid into my bank? $6,000. And I'm going to times that by 100. So again, bring up my calculator. Let's just do that. What is it? 540 divided by 6123. And then I'm going to multiply that by 100. Gives me, there we go, 9%. Ka-ching. I'm going to try the next example here, right? So how much interest did I get in that situation? Well, I got 500. Oh, dear me. I got $558.50. So I'm now going to change my calculation. Let's do this. I got $558.50 divided by 6123 times by 100. Hit enter. Oh my gosh. So obviously that's quite a long number on my calculator, 9.30, but we're going to round to 2 decimal places in this situation. And what did we find out? Well, there was 9.31%. I've got more interest, so it must actually be a higher rate. And again, if I take this difference here, $562 and 84 cents, 562.84, and I times that by 100. Again, I'll just do one more calculations. 562.84 divided by 6123 times 100. Hit enter. There we go. 9.38 and 9.42. So have you now thought of an example or a real world situation where getting more interest can be good and bad? Well, obviously, if you have a savings account, you want more interest. If you put money in and invest it, you want more interest, don't you? Because you're like, give me the money, me want to be rich. What about a mortgage? Would you want them to be charging you daily for a mortgage? Well, hold on a moment. If you're charging you daily for a mortgage, you're ultimately going to end up paying a lot more. And so with a mortgage, you'd actually want them to be charging you annually. And if you can find a bank in the world that does that, you are very, very lucky, because actually banks pay interest daily on both savings accounts and mortgages. All right, so I've already gone through this, and again, these notes up there are up there to sort of help you and download, and you can write all over them. In fact, if you want to, download them now, print them out, and then sort of write all over them as I'm talking, because there's only so much information I can squeeze on one note. But again, if you want to just remind yourself, the rate of interest was how much interest I got. So for highlighting that one, $558.50 divided by the initial amount before the interest, which was $6,000. Times by 100, and that would have given me the 9.31%. But can we do it in another way? I should, Coco. We can use our CAS calculators. And as it turns out, this one I'm highlighting here now is the syntax, if you will, for the TI Inspire. And the one below, just to be different, is the syntax for the ClassPad. And the ClassPad seemingly do it the other way around. Now, there is a way of getting your calculator to work this all out for you without having to do the table and the spreadsheets and all the numbers and finding out the interest. So obviously, let's do that now. So for the TI Inspire, you have a function called EFF. And again, if I bring up my calculator here, you go menu. Oh my goodness, you go menu, finance, interest conversions, effective interest rate. Now, it's also important to notice that there's nominal interest rate because you can do it backwards as well. We can actually give you an effective interest rate and you can get it back to a nominal. That's that annual interest rate. So when I hit effective interest rate, up comes EFF. Now, the formula says the next thing you're going to do is put in the nominal rate of interest, okay? So that's the APR, that's the PA amount. So the questions we were dealing with, I had a PA amount of 9. I'm going to do comma. Then it says the compounding periods. How many times was interest added? So for example, with the first one, I was just paid once. So if I now do 9, 1, hit enter, it's 9%. That sort of makes sense, doesn't it? But if I do EFF of 9, 4, because I think my next one was quarterly, right? So 9, 4, I actually get that 9.31. So if we go back, was it 9.31? Absolutely. Right? So your calculator can actually work out this effective interest rate with using that simple function there, and it's used quite a lot. Right, so there we go. So this is a screenshot just showing you how I got all the individual calculations. So remember, the 1 was annually, 4 was paid 4 times a year, so quarterly, 12 monthly, 365 daily. Now, obviously, a nominal interest rate, I can go backwards, as I said a moment ago, if I was given an effective interest rate. So let's say I've got my effective interest rate at 9.31. And again, I knew that that had been created because of 4 monthly or 4 payments. Then basically, you'll notice that all of these values pretty much go back to 9. All right. Now, obviously, the reason it doesn't go exactly to 9 is because I've rounded these values here. So your calculator does the best that it actually can. If you are following the Cambridge textbook, and apparently this is one in previous years, I don't remember seeing this, but there is a formula that you can actually work out using a formula, and I think that's supposed to be effective interest rates, but anyway, you can use this formula here, where little r is the nominal rate, REFF will be the effective interest rate, and N will be the number of times the interest compounds per year. Now, I don't know about you, I'd rather use my calculator because that looks really, really confusingly complicated. Brooke would like to borrow 20,000 that she will repay entirely after 1 year. She's deciding between 2 loan options. 5.95% PA compounding weekly and 6% per annum compounding quarterly. Calculate the effective interest rate for each investment. We can do that. It says calculate effective interest rate. So I'm going to use my formula EFF. Now, obviously, because I've got my keyboard here, I can just type that. 5.95, comma, compounding weekly. How many weeks are there in a month? 52. Hit enter. And what I get, what does it say? She's deciding between 2 low options. So I've got 6. Let's round it to 2 decimal places, 13%. So that's my effective interest rate. She's really going to end up with 6.13%. Next one, what is it? 6% compounding quarterly. So 6, 4, hit enter. What do I get? I get 6.14%. Oh, there is a difference, a very minor difference. And obviously the trick to the question here was the people who can't actually round to 2 decimal places. I'm really sorry, guys, but you must round. You must learn how to round. Which investment option is best and why? And again, this comes down to, do you understand the context of the question? Because she is borrowing money from the bank, right? She's not investing it, she's borrowing money from the bank. She wants to pay the smallest amount of interest possible so that she doesn't end up paying the bank more than she needs to, which would suggest, therefore, that she would have to choose investment option A. Marissa has 10,000 to invest. She chooses an account that will earn compounding interest at the rate of 4.5% per annum, compounding monthly. Use a CAS calculator to find the effective interest rate. So again, what are we going to do? So we want EFF. What was my nominal rate? 4.5, because it's the per annum, comma, compounding monthly. There's 12 months in a year. So if I do EFF of 4.5, comma 12, hit enter, I get that my effective interest rate would be 4. What is it? How many? 3 decimal places? 594. All right. So, and don't forget the percent sign after, because it is a percent. Here are some VCAA questions. Love VCAA, thank you very much. The nominal interest rate for a loan is 8% per annum. Again, I've seen the word nominal, it's bound to be effective. When rounded to 2 decimal places, the effective interest rate for this loan is, and here's the trick of the question, not. They do that a lot now. They try and do it on their head. So The minute we're talking about this effective interest rate, what I'm going to need my calculator. So is not. So 8% per annum. So EFF 8, comma, right, per annum when the interest is charged daily, 365. Hit enter, what do we get? 8.33. Well, it says 8.33. We're looking for the one that's not, i.e. is wrong. A cannot be the correct answer. What about the next one? EFF 8, comma, weekly. That's 52 weeks in a year. Hit enter, 8.32. Shucks, that one's also right, so is not the right answer. What about the next one? EFF, when interest is charged fortnightly, 8.26. And that gives me 8.32. And again, the trick here was a lot of people don't know how to round to 2 decimal places. And if you don't get a lot of practice, it's used over and over again and could probably gain you about 10 marks in your exam. So in this situation, C was the incorrect answer. Or the correct answer, because it was incorrect. Anyway. This one here, probably a little bit beyond the scope of this particular section of work because it's sort of an amortization table, but you should still be able to understand the logic behind it as I explain it. The annual interest rate for this loan is 3.6%. All right, so there's my nominal rate. Interest is calculated immediately before each payment for the loan. Repayments are made. Hold on a moment. They haven't given me an interest rate. No, they haven't. But if you go back to the formula I told you earlier, the rate of interest is given by the interest divided by the previous balance, or what the interest was created from, times by 100. So actually, I can work out my interest rate by doing 900 divided by 300,000 times 100. All right, so put that into my calculator. And again, I've covered over part of my screen, but 900 divided by 300, 900 divided by 300, 1, 2, 3, times that by 100, gives me a rate of 0.3%. All right, so that's 0.3%. So what we're saying is that this interest rate here is 0.3%. But my yearly interest rate was 3.6%. So what must I have done? Well, I've done the 3.6 divided by something has given me that 0.3. So let's just switch it up. Let's just say 3.6 divided by 0.3, and that gave me 12. So when I do 3.6 divided by 0.3, it told me that there were 12 compounding periods. That's what this stands for. There's 12 well, hold on a moment. 12 compounding periods would mean monthly, wouldn't it? Oh, well, in which case, C there would have been my correct answer. And there we go. Thank you very much for watching. That is the end of this video. Again, there is Maffs Guru there if you want to head over and sign up. Absolutely free. Downloadable notes, these videos all in order, time codes, exam questions. God, could I be any more helpful? But I'm pretty much done for this video. Thanks very much. If you have already subscribed on YouTube, that'd be greatly appreciated. Follow me on Instagram and Facebook and all those type of things. And hopefully I'll look forward to seeing you in another video. Take care, guys. Bye-bye.